Okay, so I'm going to run through some examples from the factoring class from a few days ago. I'm going to start with how to expand a polynomial. So we take the first term in the parenthesis and multiply it by each term in the second set. So I get x squared from here times x squared there. X squared times minus 2, it could be minus 2x squared. And then I take the second one, so I get 4x times x squared and 4x times minus 2, so it's going to give me minus 8x. And then I got 1 times x squared and 1 times minus 2. All right, now I'm going to go through and find, I'm going to simplify first. So let me go back to red. So this gives me x to the 4th. And that's not going to change, but I'm going to combine it later. This gives me 4x cubed, and then minus 8x, and plus x squared minus 2. I'm going to go and get purple. So there's only one x to the 4th. So we got 1x to the 4th. We actually have minus 2x squared plus an x squared. So it's going to give us minus x squared. I have 1x to the 4th, or 1x cubed term. So I get, and then putting it in standard form, I get x to the 4th plus 4x cubed minus x squared. I only have one x term and one constant. So that would be my polynomial expanded in standard form. Okay, for the next one here, I'm going to factor out common terms. So when I look at this, I get 6 times 5, and then I get x to the 5th can be written as x times x to the 4th. 21, that's 3 times 7, x times x squared, and then 3 times x. Now as I look through here, 2 of the terms have a 3, and this one, if I refactor this term, instead of 6 and 5, I did as 3 and 10. So I did that on purpose so I could show you that you don't have to get it right on the first time. That's a times. Okay. So you can see that each term has a 3 and an x. Now what you don't see here is that this is 3x times 1. So I'm going to circle each one of these. And the 3 and the x's aren't together, but I'm going to pull all of those out in front. So I get 3x, and then what's left behind, so after I take the 3x, I got a 10x to the 4th. I got a 7x squared. And then that's gone, so I got the plus 1. And that is my expanded form. And that does actually factor. I didn't intend for it to. But let's see what happens if we follow it a little bit further. So we'll have our 3x, And 10, whoops, can factor into 5 and 2. And then 1 factors into 1 and 1. So I get 10x to the 4th plus 5x squared plus 2x squared plus 1. And that combines to give me a 7x squared. And so this would be, let me go back to black here. So the completely factored form of this would be 3x 3x 5x squared plus 1 times 2x squared plus 1. All right. So here we have one where we're supposed to factor by grouping. So I group these together. Now this has a minus, so it's kind of hard to do minus. There's a big plus in between those two parentheses. So it's this group plus this group. Okay, so looking at this group, I have a 3 that can come out and an x squared that can come out. So I can rewrite this as 3 times x squared times x, and I can rewrite this as 3 times 3 times x squared. So that's my first group. And I'm going to keep working with this group. So I've got a 3x squared here and a 3x squared here. So I pull that out front. I get 3x squared. And then what's left behind is an x plus 3. Now, going to look here at this set of parentheses, I have a minus in both places, so I can pull that out. Do it right here. So I get 12x. Now if I pull this minus out, it becomes plus 36. Now 12x can be factored into 3 times 4x. And 36 can be factored into 4 times 9. That doesn't really help me though. I guess it does kind of. 3 times 4, and 9 is 3 times 3. So I can factor this into 3 times 4x and then 4 times 3 times 3. And so have a 3, 4 for each one of those. So that comes out in front. So I got 3 times 4 is 12. And what's left behind is an x plus 3. Okay, and now we have this that's common to each term. So we pull that out in front. And what we have left is a 3x squared minus 12. Now to factor completely, I see that I have a 3 here, and 3 is also a factor of 12. So I can factor a 3 all the way out front. And that's going to leave me, so this and this is gone all the way out to the front. Leaves me with x squared minus 4. Oh my goodness, I didn't really plan for this, but this factors. So if I had wanted to make this, it would have not worked. But okay, so this is a difference of squares. So I'm going to go to the next page. I get 3 x plus 3, x squared minus 4. So that stays the same. And then I factor x squared minus 4 into x plus 2, x minus 2. And so that really was way more factoring than I thought was going to happen, than I had planned when I made the problem. That you just take it one step at a time. And when you get done, you look and say, oh my goodness, there's more factoring that can happen. Okay, so that's probably way harder than anything on the homework, but it's doable. All right, the next one. This is factoring trinomials. So what I do, if this is going to factor, it's going to factor, this has to be a product. And it can be 2 times 3 or 1 times 6. Now, I got in such a big hurry and I was so excited that I forgot to do a couple things. First of all, we know that since this sign in front of the constant is negative, we have different signs. So one is going to be positive and one is going to be negative. That is sign. Okay, this one tells me that the bigger number is going to be negative. Now, when I look over here at these, they're going to have different signs, so I need them to subtract to -5. So if these had the same signs, they would add up to 5, or they would be -5. But one of the signs is going to be positive and one of them is going to be negative. So let's pick this one, even though it's not the right one. And let's see what happens if we're not paying attention and we say, well, 2 times 3 gives me 6 and 2 plus 3 is 5. It's that one. So let's see what happens. So I take x minus 3. The bigger one's supposed to be positive or negative, and x plus 2. So I get x squared plus 2x minus 3x minus 6. And what happens is that combines to give me a minus x, which is not what's sitting there. Right there is a minus 5x, and this is a minus 1x. So it doesn't matter what I do. If so let's say, okay, I'm totally convinced that it's minus 3. It's 3 and 2. So I'm going to change this to a negative and see what happens. So when I expand, I get x squared minus 2x, and then minus 3x. That gives me minus 5x. But right here, when I have minus 3 times minus 2, that's a plus 6. So now I get minus 5x, but I have plus 6 instead of minus 6. It doesn't matter what I do, any combination of signs, I'm either going to not get minus 5x or I'm not going to get minus 6. So this is not the right factors. So let's take the 6 and the 1 and go to the next page. Not the next, but I have to insert. Okay. So we get x squared minus 5x minus 6, and we know that the factors are now 6 and 1 because 2 and 3 didn't work. The bigger one is negative, so we get a plus and a minus. Expanding to check, x squared plus x minus 6x minus 6, that combines to give me minus 5x. So this is the correct factorization. Okay, so here, this can factor into, oh, don't get too excited. This says, since it's positive, we have the same sign. I don't know if it's going to be positive or negative yet. I just know they're both the same. I look here, and since it's positive, they're both positive. So it's going to factor into something that looks like this. And I just have to figure out what goes there. There's a lot of different choices. There's 12 and 1, but that doesn't add up to give me 7. There's 6 and 2, but that adds up to give me 8. 3 and 4, and that adds up to give me 7. So 3 and 4, x squared plus 4x. Now I have to check. And so that is my 7x that I'm looking for. So this is the correct factorization. Okay, now here's one. The signs will be different. The larger one is positive. And so the factors of 14 are 14 and 1 or 2 and 7. So 14 minus 1 is 13. That's not going to work. 7 minus 2 is 5. So this is the correct one. I know the signs are going to be different. And the bigger one goes with the positive sign. The smaller one goes with the negative. Okay, now I check. X squared plus 7x minus 2x minus 14. That's a minus 14. So those together combine to give me 5x, which is what? So this is the correct factorization. Okay, now this one is a little different. We got a 2 here, and we have a 3 here. So 2 only has one factorization. It factors into 2 and 1. And 3 has one factorization. It factors into 3 and 1. So now the question is, where does the 3 go and where does the 1 go? And again, I got so excited that I forgot to evaluate my signs. So this says the signs are different. So one's going to be positive and one's going to be negative. And this tells me that the bigger one is going to be positive. Okay, so I'm going to have to figure out how to arrange 3 and 1. So I'm going to do it wrong, just so that you know what happens. I still don't know, I'm still not quite sure on my signs. So I get 2x squared, and then 2x, 3x, and 3. Now, the sign has to be different. So this one's going to be negative. The bigger one is going to be positive, so 3x is bigger than 2x. So that means 3x, and then minus goes there. So that will give me the signs that I have here. So 2x squared minus 2x plus 3x minus 3. But that does not give me plus 5. It gives me plus 1x. So it didn't work. Okay, so there's really only one other way I can factor this, because the only factors of 3 are 3 and 1, and the only factors of 2 are 2 and 1. I must have these backwards. So I am going to start over. Let's just get a new page. I have 2x squared plus 5x minus 3. And I said we can have 2x and x, and the signs are going to be different. Now, the 3 didn't work here last time, so I'm going to put the 3 here and the 1 here. So I'm going to get 2x squared, and that's going to give me 6x. That's going to be bigger, and I need the bigger to be positive, so plus. So this one has to be minus. And so that combines to give me the plus 5x that I was looking for. So this is the correct factorization. All right, this one's a little harder because 10 factors into 10 and 1 and 5 and 2. It's 9 factors into 9 and 1 and 3 and 3. So now I have to start figuring out what to do. And I may have to do this several times to get it right. So the signs will be different. And the larger one is negative, so bigger is negative. Start off, I'm not going to put my x right up against the parentheses because I know I'm going to have to put something there. So I'm not sure what to try first. I can kind of do something here where I do 5 times 3 is 15, and 2 times 3 is 6. 1 is positive and 1 is negative because remember the signs are different. So minus, plus, I don't know, that's not going to be 27. So it's not 5 and 2 and 3 and 3. So let's pick something else. Let's pick 5 and 9, and then minus 2. That's not going to work. I haven't tried everything yet. So it could be 5 and 2 and 9 and 1, where the 2's go together. The 2 goes with the 9, 18, and then minus 5. I don't know. That's not going to be 27, so still haven't gotten it yet. Okay, I think we've eliminated 5 and 2 as our factors. So let's go back. Let's try 10 and 1. If I look at 10 and 1, I'm trying to get 27. So 10 and 3 is 30, and 1 and 3 is 3. So this might work. So I'm going to do 10 and 3 and 1 and 3. Now I check 10x squared. This is going to be positive because it's going to give me 30x, and the bigger is positive, minus 3x. And then minus 3 plus 3 is going to be, with multiply, it's going to be minus 9. So when these combine, I get plus 27x, which is what I'm looking for. So this is the correct factorization. And sometimes, I mean, how many did we try? We tried 1, 2, 3 before we got the one that was correct was the 4th try. So that happens sometimes. Okay, now we're at the difference of squares. So x squared is a square and 64 is a square. So you need to have on your note card the formula for the difference of squares, and that is a plus b times a minus b. And so following that formula, this is a and this is b. So I get x plus 8, x times x minus 8, and that'll be my factorization. I can check it, but when I have this formula, it works. Okay, so here's another difference of squares. So 25 squared, 5 squared is 25, and x squared is x. So 5x squared is 25x squared, and 9 is 3 squared. So this whole term is my a, and this is my b. So I get a plus b times a minus b, and that's my factorization. Okay, this one's kind of tricky. 625 is a really big number, but 625 is 25 squared. And x to the 4th is x squared squared. So 25x squared squared gives me 625x to the 4th minus 4 squared. 4 squared, 16. So this gives me 25x squared, so that's my A. There's my B. So 25x squared plus B, A minus B. All right. Now here, 25 is 5 squared. And then we have an x squared. So this is another squared term. This is a difference of squares. So I can write 25x squared is 5x squared minus 2 squared. So there's an A and a B. So this becomes 5x plus 2, 5x minus 2. And this part comes down. It doesn't, there's no formula for the sum of squares. So I get 25x squared plus 4 times 5x plus 2 times 5x minus 2. And that is completely factored. Okay, this is the difference of cubes. So this is another formula that you need to have on your note card for the test. Difference of cubes. So that's A minus B in parentheses times A squared plus AB plus B squared. And so I rewrite this as x cubed minus 3 cubed. So there's A and there's B in the formula up here. So I get A minus B, so that's x minus 3, times A squared, which is x squared, plus A times B. So that's 3 times x, or 3x, plus B squared, plus 9. And that is my factored form. And here's the last one. This is the sum of cubes. So that's A cubed plus B cubed equals A plus B times A squared minus AB plus B squared. Okay, so x, or 8 is 2 cubed, and x cubed is x cubed. 125 is 5 cubed. So there's my A, and there's my B. So I rewrite this. So I plug it into the formula, A plus B. It gives me 2x plus 5, and then in parentheses, and then A squared. So that's 2x, but the whole thing squared, minus A times B, so that's 2x times 5, and then plus B squared. So working with this piece, to simplify it, I get 2x plus 5. I get 4x squared minus 10x plus 25. And that is my factored sum of cubes.